Hello and welcome to this video. I want to create a set of videos to provide a basic tutorial for the Lua programming language. This is particularly aimed at a program called EEP, which is a railway simulation program where you can create a virtual model railway within the EEP program and then run and operate that virtual railway layout with trains and everything else. EEP provides users with the ability to create a Lua program to then control or operate various aspects of their layout however they want to do that. So this is a general Lua tutorial, but certainly in later videos some aspects will be aimed towards EEP. If you're learning Lua as a language, then obviously if you wanted a sort of fun way to use your newly acquired programming skills, one option would be EEP, where you can create nice little model railways and operate them and test or develop your Lua programming skills to do that. Anyway, getting on with this video, I want to basically cover some of the essential basics of the language within this video, and then I'll deal with specific aspects in subsequent videos. This video I'll do the basic syntax, the data types, the simple operators, and some of the basics within the language. So EEP does contain an editor. Really it's at best only a simple text editor. I use Notepad++ to create Lua programs. There are a variety of code editors that you can download. Notepad++ is just one that's freely available. It does have a little bit of support for Lua, but Lua has fairly limited syntax checking anyway. So there are also a wealth of resources available for Lua that you can download. If you Google Lua, there's development environments specifically for it, editors for it, etc. So this is using Notepad, but I'm just going to cover some of the basics. So within Lua programs, comments can be done as --, so --, comment. You can have multi-line comments using --, square bracket, and that's all fairly sort of simple. Assignment, again, very straightforward, just using equals. Variables are not declared in advance and are dynamically typed, so I can have a equal to 0 and then I can say a is now a string, and that's perfectly valid, and then I can assign a as a table, and all of that is fine. So variables are dynamically typed and can be assigned any data value at any time. The basic data types are numbers, strings, boolean, tables, nil, functions, and user data. I will not, well, I don't plan to cover user data in these videos. I will deal with all of the other data types. It's important to recognize as well that functions are a data type, so I can actually assign functions, pass them as parameters, return them from functions as results, and assign them to variables. So just like everything else, functions are a data type in their own right. So covering variable names. Variable names can't start with a numeric character, but can otherwise be whatever variable name you want. They are case sensitive, so lowercase a is different to uppercase a. It's also important to recognize, as I said, that they don't have to be declared in advance. So if I have print a new variable and I haven't assigned or declared a new variable, that will not generate any syntax warnings. It's completely valid to have that there, and it will simply be evaluated as nil when it's encountered. You therefore have to take some care with typing, because if you mistype a variable name, it won't generate any errors or warnings, and it will just be interpreted as a new variable with global scope. All variables have global scope unless they're defined implicitly or explicitly as local. So if I have microphone's in the way, so I can't type properly, but get there eventually. So if I have that, then here that will print 10, it will not print 0. In the subfunction, the assignment will save to the global variable and therefore override all of the values from higher level functions. So you have to be aware that unless you define something as local, it will have global scope. Now you can also define variables to have local scope within, for example, if statements. So I can declare a local variable here and use that within the if statement, and it will only exist within this structure. For loops also automatically define their loop variables as having local scope. So I can do x equals v times 4, oops, but I can't access v outside of that for loop. The two loop variables I and v will only have local scope to this for loop. There are a set of comparison operators within Lua. You have equality, so a equals b. These will only return, this will only return true if it's the same on both sides. So there are some special exceptions that I'll come on to in subsequent videos where you might think that it will evaluate to true, but it won't. Particularly with tables, because tables are generally accessed by reference, and therefore you can have some equality issues. You have equals, you have greater than, you have less than, you have greater than and equal to, greater than or equal to, you have less than and equal to, and in Lua the not equals is tilde equals. So if you're used to C++, you can't have exclamation mark equals, it's tilde equals. So you have a set of basic numerical operators, so plus, minus, divide, times, divide, and modulus. They're fairly standard. You have logical operators of or and not. These need to be sort of explained slightly. In Lua, the only things that evaluate to false are false itself, so Boolean false, and nil. Everything else evaluates to true. So if I have if 0, then print true, else print false, and that will always print true because 0 along with everything else will evaluate to true if and the only things that evaluate to false are false itself and nil, nil being its own data type. So you have the standard comparison operators and the logical operators A and B. This will return B if A evaluates to true, and it will return false if A evaluates to false. So if you have that will print 5. So because the first value evaluates to true, it will return the second value irrespective of what that is. Or, so A or B, that will return the first value if it evaluates to true, otherwise it will return the second value. Again, it will actually return the actual value rather than true or false. So 5 or false will return the number 5. You have string concatenation, so if I say S is a string, I can concatenate another string, but I can also concatenate numerical values, and there's automatic type conversion. So with the dot operator, which is the string concatenation, if either of the parameters is a number, it will automatically be type converted to a string. Similarly, strings will automatically be type converted to numbers for numerical functions, numerical operators. So there, that print statement will print 9, and each of the strings will be type converted to a number to perform the numerical operator. The type conversion will take into account leading minuses. So what you can do with the logical operators is, if you have A and B or C, here A has higher precedent than OR, so this will return B if A is true, and it will return C if A is false. So with a slight caveat, it's similar to that from C++. So the only issue with this is if both A and B are false, that will return C. It won't return false, whereas that would return false, i.e. the value of B. Sorry, forgot that right, yes. Yes. So Lua also doesn't include a C++ type function, so A++, A minus minus, plus plus A, none of those work within Lua. what Lua does do is you can assign a number of variables at the same time. So I can have A, B, C equals X, Y, Z. What it's important to know is the value list is evaluated first before any assignment takes place. So all of these values are evaluated before the assignment is performed. That means you can do this. So you can switch X and Y around within one line of code. That avoids the typical 3 lines of code to switch those two values, because these values are evaluated all completely before any assignment takes place. Similarly, in a for loop, the values for the for loop are all evaluated before the first iteration of the for loop and are then not re-evaluated on each iteration. Also, the loop variables will have local scope, so those two variables are only valid, as I've said, within the scope of this for loop. But it's important to recognize that the data values for the for loop, in this case the list, are only evaluated once on entry to the loop and aren't re-evaluated on each iteration of the loop. Lua has a set of maths functions as well. There is a fairly sort of basic standard maths library that isn't part of the core Lua engine. So the core Lua engine only includes the basic add, subtract, multiply, divide, modulus functions, but there is basically an extension which is a maths library that includes ceil, floor, those two do rounding, min, max, sine, cosine, tangent, exponentials, logs, log tens, and a sort of few other functions. You also have math.pi to return pi, and you have a random number generator. So if you do random, that will generate a random number between 0 and 1. Random with a number will produce a random number up to that value, and math random AB will produce a random number between A and B. So that's your sort of basic math library. I won't go through all of the maths functions here. There's plenty of text around on the net to cover them, but it's a basic set of maths functions for cosine, sines, absolute values, min, max, etc. You have degrees and radian functions as well, because the maths library works in radians. So if you want to program in degrees, you have to convert that into radians in order to use the sine, cosine type of functions. But easiest to just look at those specific functions if you want to use them. As I've said, functions as well are a data type in their own right. So if I have a function, I can use that as a data type, and I can pass it as a parameter to a function call. I can return it as a result, and I can assign it to a variable. So that function declaration is equivalent to saying foo is a function of a and b, and then the content of the actual function. That can be quite useful in a number of ways. You can dynamically create functions, you can pass them, you can also use the global environment within Lua, so you can save dynamically generated functions within the global environment. There is a semicolon separator, so if you put multiple statements on the same line, you can separate them with a semicolon, but that is not a mandatory feature of the language. You can do everything without any semicolons, and it will execute completely fine. But there can be a problem in that it is valid to start a statement with in some circumstances, with an open bracket. So if you did that and for example said a equals b, and then your next statement started with an open bracket, that would look like a function called b with some parameters, whereas what you actually want to mean is that. So if you're starting a statement with an open bracket, be careful, and in those circumstances you want to explicitly put a semicolon separator in there, just to be safe and sure. I'm going to cover tables and other data types separately in a subsequent video, so that is the sort of main aspects of the language. We've covered the data types, variable names, and basic assignment, the equality tests, the basic numerical operators, logical operators, comparison operators, string concatenation, automatic conversion of numbers to strings for string concatenation, and automatic conversion of numbers to strings to numbers for numerical operators, and the way in which you can assign multiple data values in one go to multiple variables. I think that's enough for this first video, so I'll cover further aspects in subsequent videos, and I hope you found this useful. Thank you for watching.